Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I've been working hard, but what does that actually mean? By the end of this video you should be able to tell me, what do we actually mean by work? How does work relate to the amount of energy transferred? And how can we calculate the amount of work that's been done?
So when we normally use the word work, what we're actually talking about is a job or a task that you've got to do. Well, it's sort of the same in science. It's just that when we talk about it in science, it's a force that's doing the work. So if we think about me pushing this rock along here, what I actually think about is my object is being moved by me applying a force to the object. And we say that work is being done to the object when it starts moving. Okay, so when I apply a force and my object starts moving, I can then say that work is being done to it. Now, when the object starts moving, obviously it is starting to gain kinetic energy. So we can say that a force transfers energy to an object. In this case, the object is my rock. So if you think about it, the amount of energy that's being transferred to an object, that we measure in joules, of course, the same as normal, is actually the same as the amount of work that's being done to that object. So for example, if I lift an object through a height, it might gain, let's say, 20 joules of gravitational potential energy, and I can say that I've done 20 joules of work to that object. So we can really see that energy transferred is the same thing as work done. Now, the amount of work that has been done does depend on a couple of factors. Firstly, it does depend on the size of the force that you are applying. And secondly, it depends on the distance over which you apply that force. And these two factors can actually be used to calculate the amount of work done, because if I multiply the force I'm applying by the distance I apply it for, what I actually get out of that is I get the amount of work that's actually been done. So we can see that this calculation here, work done measured in joules, is actually equal to the force measured in newtons multiplied by the distance. And of course we can abbreviate that to W, big W, equals a capital F multiplied by lowercase d. So let's think back to me pushing that rock again. So if I push that rock a total distance of 2 meters with a force of 75 newtons, how much work have I actually done? So let's do it like we're doing it in the exam here. First thing I'm going to do is write down the equation I'm going to use. W for work equals F for force multiplied by D for distance. Then I'm going to substitute in my figures. So it's a force of 75 newtons multiplied by 2 meters. So you can see that that is going to give me the amount of work done is 150 joules. So let's do the math on that one with a little exam question here. The question says a car travels a distance of 20 meters when a motive force of 7,000 newtons acts upon it. And they're asking me how much work is done to the car. So pause me now, work it out, and then start me up again, and let's see if we get the same answer. So hopefully you've done your workings out now. And so our question was, we've got a distance of 20 meters and force applied of 7,000 newtons. How much work is done to the car? Well, let's have a little look. Of course, the first thing I've done is I've written out the equation I'm going to use. W equals F multiplied by D. Then I've substituted my values in. So I've got 7,000 multiplied by 20 there. So of course that's given me the amount of work done is 140,000 joules. And of course that's the same as the amount of energy that's been transferred. So that's pretty easy, but if we think back to me pushing my rock again, you realise that it's not just my pushing force involved, there's also the resistive force of friction at play here. Now, if you rub your hands together, it's your muscles that are actually doing the work, and they're doing that work to move your hands and to overcome the friction which exists between your two hands. So if your muscles are doing the work, which we know is the same as the amount of energy transferred, then where is that energy going? Well, if you rub your hands together, what happens? You can feel they start to get hot. So what we can say is that any work done to overcome friction is transferred into energy as heat.
So that is everything we need to know about work, energy, how they're related to each other, and how we can calculate them. Any problems at all with that, don't hesitate to tweet me at Mr_Pepperell, email me or message me on the VLE, and I'll get back to you ASAP. Thanks for stopping by.